Hello and welcome back to the A4Q Global Testing Summit. I now want you to welcome Vipul Kocher. He is an entrepreneur focusing on software testing. Currently, he's building an AI MA model testing product in his startup testing.com. In the past, he has created and excited testing services, assessment, and skilling companies. And in his presentation, you will learn more about testing ML models. And we want to encourage you to feel free to ask questions in the comments. Send us your questions, and we are happy to answer them. We are excited for your presentation, people, and have a lot of fun and good luck.
Thank you so much. Um, how do I get my presentation? Yes, thank you so much. I have it now. Namaste from India. Today, I'm going to talk about my experience of building an AI model testing product or a machine learning model testing product, to be specific. This presentation is not about promoting my product, but this presentation is about where are we with respect to AI ML testing, and what are the trends, what are the challenges, and how do you really test a machine learning model. So that's basically the focus of my presentation today. First half of the presentation, I'm going to talk about some of the challenges, let's say first 30% of the presentation. And after that, I'm going to talk about the product and how do we really test it and so on. And in between, if you have any questions, I would be happy to answer them. If you have any question that you would want to ask later, feel free to put it in chat as well. Let me introduce my introduction to AI first. Around 2015, I was working on creating world's first AI testing certification. And that is when I got interested in AI big time. Although during the college time, there was a bit of artificial intelligence in terms of fuzzy logic, in terms of neural networks and so on, when I was doing my bachelor's. However, the real interest in AI came in terms of my trying to figure out how do you test AI applications. And interestingly, 2015-16, there was hardly any information available. I struggled for a year and a half to put together a syllabus with knowledge coming from experience, knowledge coming from different people, but there was so little of it that we couldn't really do much. Finally, something happened, some magic happened. Got in touch with some professors, some other professionals, and we came together and created world's first AI testing certification called AI United, Artificial Intelligence United. At the same time, maybe a few months later, A4Q also released their certification. And then, at some point of time, we all got together and created ISTQB's AI testing certification, which includes A4Q certification, which includes AIU, and one by Korean board and so on. It was a struggle to put together the certification. We went to a lot of companies, we went to a lot of practitioners, asked them, how do you test it? What all do you do? And in many cases, we got blank looks. What do you mean testing? A CTO said, why do you need to think about testing? All the testing that you want to do for AI ML models is already built into it. And I asked, okay, so please tell, how is AI ML testing built into it? So they started saying, when we create a model, we make use of matrices like accuracy, like confusion matrix, and so on. That is part of it. Then you have cross validation. So you have splitting of your data set into training, validation, and testing data set. What more can you want? And it was a hard question to answer. And it was easy as well. Because I didn't need to get into the merits of what all do you test for, what are the matrices, who tests it. All that I needed to ask was, are your models, after getting tested, after having an accuracy of 90% or 95% or 99.9%, do they work flawlessly in real world, or do they fail in the real world? And indeed, AI was failing. That is the kind of thing that shut up a lot of people. Now, I have no idea what are your expectations from this session. I'm not going to talk about what is AI/ML, done that enough number of times. Not going to tell you different types of learnings and so on. I am going to talk about how do you test ML models. So it assumes that you already know what is AI, what is machine learning, what are the models, and that there is a need for testing that I can explain. And then I will tell you how we test it and what kind of product have we built. And even if you don't have that product, how can you really test it? So that is basic idea of what I'm going to present today. So there are challenges and there is a need for testing. I think it was in early 2000s, Y2K bug had just gone away, and after that, independent verification validation sort of started to happen, which was a nice thing. Initially, a lot of people asked the same question. Well, my developers are writing the code and testing it. Why do we need independent testers? I don't think we need to ask that question today. AI is passing through exactly same phase. There are no standards on testing. ISO and IEEE, they're working on it. Co-authors of the ISTQB syllabus, co-authors of mine, Stuart Reed and Adam Smith, they are basically, Adam and Stuart are part of ISO. They are trying to put the standards together. ISTQB has done its contribution, but still we are very far. And so when you go and as an independent tester, you talk to the developers who are developing AI models or ML models, you talk to data scientists, ML engineers, and they also come up with the same question. So what's the big deal? So even before we build the product, I'll give you an example of a company. So my company, Test AI, we started as a AI testing services company. Our idea was we are the first AI focused testing services company. No, we are not using AI for automation. We are there to only test AI models and AI applications. So we were doing that. And every time we went to the customers, they said, what's the big deal? What are you going to test? Oh, we already know this. And the interesting thing is, when we talked of things like explainability, which I'm going to explain in a moment, we talked about metamorphic testing and so on. Somebody had heard the name, they didn't know, but they would not admit that they didn't know. So this is one of the first challenges in ML testing that you will get, that your ML engineers or data scientists, they may refuse to believe that you can add any value by your testing. Of course, they are right also in many cases, because many a times the testers themselves do not know what kind of testing can be done. So first, let's take a look at the challenges, then let us look at how do we test it. So, I'm sorry. What are the challenges? When you have AI models that get deployed, they can make silly mistakes. For example, if I'm merging two pictures, and size can be different, or a man can be identified as a mountain, and those kind of things. Hilarious, maybe. No big deal. But then you have the whole reputation of the company on the wire. For example, Microsoft released its chatbot Tay, and within 24 hours they had to bring it down. Why? Because this was supposed to be a self-learning kind of a system, and they had a similar system working in China already. But here online, when people interacted with the chatbot learned from the interaction. So naturally, if you are interacting with the chatbot using racist terms, sexist terms, abuse, that is what the chatbot is going to learn. Microsoft had not put any filters, any gating criteria, any type of learning that should not be learned. When your child goes out and learns bad words, you tell the child not to use those words. That's the part of the learning. There was nobody to teach Tay. Within 24 hours, it was racist, it was abusive, and so on, and had to shut down. Failure of AI. Amazon, it had its tool for let's say in interviewing, and people realized later that it was biased against women. I'm sure there are many more such stories you would have heard, including driverless car accidents and so on. So we don't want AI to fail, but AI still fails. So why is AI failing? On the right hand side in this, you see this arrow in the center of the slide. These are the reasons where or because of which AI is failing to deliver. You have lack of transparency. You have releases which have not been tested well. You don't know how to test. You don't have real world scenarios. Your data is biased. So lack of technique, issues with data, issues of transparency, issues of explainability, issues of quality gateway, lack of matrices, lot of different reasons why AI fails to deliver. So you can go through the slide, take a look at things like incomplete coverage. How do I know that I have done enough testing? Well, that question cannot be answered even for normal testing, what to talk of ML-based or ML model testing. But generally, coverage is a big problem. Then, so why is coverage a big problem? Maybe I need to explain a little bit about that. Let us say you are testing face recognition. Yeah. So like Facebook face recognition, let us say. Now, when would you conclude that you've tested enough? So you have your set of data and you give it face after face after face and it recognizes it correctly. You think all my tests have passed, end of the story. And then some faces do not get recognized. So you go to the developer and say, these 4-5 faces, they are not getting recognized. And the developer will say, this is machine learning, this is non-deterministic, it will never have 100% accuracy. Some faces will always be not recognized, so that's okay. Now, how do you know whether those, let us say, 99.9% faces are getting recognized, 0.1 faces are not getting recognized? How do you know that this 0.1, this face that is not getting recognized, is part of that 0.1 which will never get recognized or which will have some difficulty? Or does it represent a big hole in your strategy? What is meant by a big hole in your strategy? Why is a face different from any other face? So let me tell you. Some woman of color was not recognized. Her face was not recognized by the algorithm. So she did a survey, she did research, and she went to some of the most commonly used face recognition software and collected both black box and white box data. She found out that the data used for training the face recognition software had 80%, 70 to 80% male faces and 20 to 30% female faces. Of those faces that were male and female, total 80% plus images were of white males and females, and then some images of people of color. So which means there were more images of black, then less of brown, and then all the skin shades that you have. Now imagine if I know this, what is the kind of test that I need to run? And she ran that test. Which is the least likely to be recognized by this hypothesis that I don't have sufficient data? So women are at disadvantage and people of color are at disadvantage. And so when she put a lot of faces, she found out that was indeed coming out to be correct. White faces were getting recognized to the tune of 90%, 95%, and white males, and black females to the tune of only 60 to 70 or 80%. So that is what we are really talking about here. So you are as good as your data, only, nothing more than that. So you have to understand how to test it. Another thing, today what you are seeing right now is my face with a off-white, yellowish background. What if there's an image, my image, where there's a poster at my back which has some faces? Should they be recognized? Should they not be recognized? How many such um, images and test cases can I create? Many. For example, profile, some angle, right? And so on. Which of these have been used in training and testing, and which of these have not been used in training and testing? When you go and talk to the developer, if you don't have this information, you cannot really do much about it. However, even if you have this information and the developer tells you, and developers all across have been telling us this, oh, what's the big deal? It is 95% accurate, so 5% doesn't matter. All I'm asking is, does it represent a class of things that are not being recognized? For example, brown people, people of Indian origin, only 1% data is there. And if you want to use this face recognition software in India, it is more likely to fail than pass. So we have to understand we are representing a class. You may also need to ask, for example, if it recognized this face, was it a fluke? What made it see this particular pixel pattern as a face? So that is explainability. When I can ask the model, or I can somehow use a technique which can tell me that what is it that the model is looking at. And this is not just for images, even for text. For example, if somebody found a tweet to be hilarious, and maybe the tweet was hilarious, but you need to ask a question: why does the model think it is hilarious? Don't assume that as a human being, what you see, what you feel, is how the machine actually operates. The machine doesn't see a face with two eyes and nose and lips and so on. A machine sees just a pattern of pixels. That's it. Similarly, machine sees just words connected to each other in some statistical manner. You have to have some techniques by which you can find out what is it that model is paying attention to, and that is called as explainability. And there are a lot of different types of explainability. Some of the good data scientists and engineers know about explainability, many do not, and that becomes a problem. So what you need to do is understand what are the explanations, and is it okay or not, and then as a tester, can I use this information to become better? And we will see that. Okay. Bias is a critical factor. We have already discussed. How can I take care of bias as well? Then, if you know your machine learning, you know I supply data. The data trains a model, and the model basically learns from this data, and then there is a learned model, or there is a model which is trained now. So all that is very good. The data is not part of the model, so we think the data is secure. The model cannot leak data because the model does not contain data. But there are interesting attacks that are available today, using which you can reverse engineer and get some critical information related to the data. For example, it is possible to extract sometimes credit card numbers or social security numbers from the models. You thought your model is safe, it is not. If I make some changes to my input and I can make the model misbehave, imagine that if there's a traffic sign and I put just one or two black stickies on that traffic sign so that it doesn't disrupt any human being, but a driverless car looks at that, and instead of stop sign, which it actually thinks this sign, or one-way sign, it thinks it is a sign which says 40 kilometers an hour or 60 kilometers an hour, and it just zooms in. A lot of catastrophes can happen that way. I'm not showing you examples of those. I'm going to tell you how do you test. Now, when I'm talking about testing, you basically need to also understand one thing, that testing is just one part, and you need to understand techniques, but you also need to look at what is risky. And for example, in banking and finance and insurance and medical imaging and so on, these are compliance driven sectors. If I use AI there, it's a big risk. So what are the big risks if you are going to test any AI ML model testing? If you are going to do any of that, then you need to make sure that privacy, fairness, security, and transparency, these are taken care in a very nice manner. Otherwise, you will face difficulties when you go for compliance. So these are 4 main tiers. Then from a testing aspect, there are black box and white box aspects of testing. Metamorphic testing is one technique that can be used to do testing. And then you have coverage based techniques, neuron coverage, for example, which can be used to do white box testing. I had uncovered, or I had discovered, a technique based on linguistic analysis of sentences of a particular requirement, and you can create a lot of tests. We are working on some patent pending things there where you can write automated tests. So I'll not talk much about that. So these are different types of tests that you can do from a testing perspective. So the compliance and testing, these are 2 things that are important that you need to look at. This is your ML life cycle, and you can look at this life cycle and say that, where can I intervene as a tester? Well, right from the very beginning, when machine hasn't even started learning, you just have the data. As a tester, you go in there. You look at the data, you ask yourself, is my data distributed properly? Is there any bias in the data? Am I missing certain type of data? Please understand, your machine learning is as good as your data only. So if you do not have sufficient data, you do not have right type of data, you do not have right classes of data, you are going to be in big trouble. And then when the machine learning engineer and the data scientists, they go and create their models, they use their own techniques. For example, k-fold cross-validation, for example, confusion matrix. So matrices, which we call in ISTQB syllabus, we call them functional performance. So how is the model performing? And out of 4, 5, 10, 50, 20, whatever number of models somebody may have experimented with, you choose one model. At that point of time, you can apply a lot of different tests related to privacy, security, model performance, functional as well as non-functional tests, right? Metamorphic testing, coverage, and so on. And then basically, usually people stop here, but we take output from these, and then we basically feed them in, we create new data, train the model again, improve the model. We call that as feedback loop. But you can stop here also and give all the bugs to the developers and say this is all good. Once you have retrained model and retested model, finally you get a model. Now with this model, you are going to integrate with the rest of the system. And you can test rest of the system as a black box model, or you may continue to use it as you like. But the moment you integrate it, after that, a lot of tests can be run again. For example, A/B tests when it goes into production, because on real data, you need to test your models. I've seen umpteen number of times that in the lab, the AI model seems to be working okay. And when we integrate it and then pass the data that we had used earlier, everything is still okay. But the moment it goes to production, it breaks. It breaks down. Why? Because the data that is coming in is not of the same format, same type, etc., as it was when I was training the model. So that's a key aspect that you need to look at. Overall performance also needs to be looked into, and so on. And sometimes what happens is that your model size is too big. Sometimes you are deploying the model on the edge. You are deploying it on the mobile devices, so you need to reduce the size of the model. So some sort of techniques like quantization, etc., can be done. And at that point of time, you need to calculate your performance matrices or functional performance of your model again, in terms of accuracy, in terms of confusion matrix, or any other metric that you might be using. So this is basically the whole life cycle view. Now, what I'm going to do is take you to some real world where how we test the product can be seen, and you can use these techniques yourself. So what is it that you are seeing? You are seeing right now, I don't know, moderator, please. I am sorry, guys. I just need to make sure that I am sharing appropriate thing. Hopefully, I would be able to share my screen. Are you able to see my screen? Somebody can probably send a message here. I need to have the screen displayed. How do I know that? Yes, wonderful. Thank you so much. So I showed you the diagram where how you basically can start the whole testing. And I said we start with the data. Here we are starting with the data. First thing that we do is look at the data. And what you're seeing right now is, for example, I have a model which does classification. So I'm using, this is a screenshot of, not screenshot, this is a report or output generated by our tool, which is automated tool for testing all these different types of tests that I told you. So this particular machine learning model recognizes different types of animals. And let us say I have 4 different types of classes, giraffe, elephant, deer, and so on. And the first thing that I see is distribution of data with respect to these 4 classes. And you can clearly see that the data is distributed more or less evenly. But there are many cases where the data may not be distributed evenly, which means there's a bias in the data, and that is problematic. So right at this stage, you start doing your testing. And then, the model that was given to us, it has certain accuracy when it was trained, when you look at the validation results. So 74.6% accuracy. So this is what the model is today. Now let us talk about model explainability first and how you can use explainability. I'm not going to get into different types of explainability. There are there is local explainability, there is global explainability, there are white box and black box methods. Not going to get into details, but show you just 1 or 2 things. Okay, so what you have here is explainability of the model. So what you see are 10 samples that have been taken which were misclassified. So of course, this is supervised classification. So I already know that this picture, for example, has elephant. But what I'm being shown here, that this picture has a deer in it. Why is my picture not being recognized as elephant? Why is it being recognized as a deer? That's a good question to ask. And if you get an answer to that question, you know whether your model is behaving correctly or incorrectly. So here, if you look at it, the elephant, right? And then you see some tree, which is a tall tree, and these red marks that you see here, they are telling you the hotspot. Those pixels in the image that are being used for determining that this is an elephant. So why are green, longish trees being thought of as an elephant, whereas the elephant, which is in blue, is relatively cool? That means those pixels are majorly getting ignored. So there is a serious problem here. I can see so there are multiple algorithms that are being used here, and you can see all algorithms are sort of, pointing to the same thing. Now, this is one example. This is another example. Another elephant misclassified. Again, you can see some sort of tree and, a longish, brownish kind of a thing. That might be recognized as a deer rather than as an elephant, which means clearly that I have a problem in my test data. All my elephants are using green background, and my model is not able to recognize these correctly. So what is the solution? One solution is, so this is explainability. This is something which is done manually. You cannot automate this. Okay. So if you cannot automate, you have to apply your mind. You have to figure out what can I do. In this case, one of the things that I can do is that I can remove all the background and have only elephants. So maybe I have 10, 15, 20, 100 of such images of elephants. So my model can recognize elephant clearly. And then I can give these images also, and my model should be then able to recognize clearly that this is background, this is elephant. So this is what needs to be done. That is one aspect of it. So this is one explainability technique and how I can use this technique. There are more things that can be done, but I'll not bore you with more details. Uh, there are a lot of different techniques which tell you which portion of the image is being used globally. The only difference between local and global explainability is the main difference between global and local explainability is local explainability explains why the model is behaving the way it is behaving with respect to one particular input. So this is in this case, for example, the explainability is for this specific image and this specific image and this specific image. Whereas global explainability, while it is on the basis of image, but it is taking into account overall images and so on. So you've seen that explainability can be very helpful. I will take you to security attacks and I'll take you to white box attacks. Take a look at this example. The same image, right? Looks exactly the same. The first image on the left hand side is recognized properly, correctly, but the image on the right hand side is not being recognized properly. Why is that happening? So what we did was, there are a large number of adversarial attacks that we performed, and we mixed the actual image with some pixel pattern, some specific pixel pattern, and that made the model to misrecognize, misclassify a given image. This can have a lot of security implications. So you can see that there are large number of such changes that we have made. Some of them recognizable as changes, some not recognizable as changes, but misclassification at a very high level of confidence. The confidence level here is 91%. 91% it is confident that this is a giraffe. Funny. So a lot of different techniques, a lot of different algorithms can be used. Now, what do we do with this? One thing is that, of course, it makes my life easy as a data scientist. All I need to do is supply my model and supply my data, and that's it. After that, the model automatically comes up with all these attack vectors. But the interesting thing is, what do I do with these attack vectors? I take these attack vectors. These are the images that have been misclassified. I take these modified images back to my training and train my model with these images once again. And we call that as feedback loop. And this time the model becomes more robust and it is no longer prone to the same attacks that I did. And if I do the same attack once again and once again, you'll find that the model starts to behave much more robustly. So this is an example of attack vectors. Both black box and white box attack vectors can be used. And these are black box attacks that I'm showing you. But it doesn't matter for us. For the purpose, this should be good enough. Now let us take a look at metamorphic testing. Now what is metamorphic testing? I think it's my duty to explain that. So I will try to do that quickly. How do I know that for an e-commerce website, if I've got some, let's say I bought 2 or 3 or 4 items of something, how do I know that the cart has right total? So pretty interesting thing. Well, I know the price of one item. I will multiply it with the total number of items and that should be good enough. What about discount? Oh, I will factor in discount also. So you have established a sort of relationship between output and input. So when you can establish different relationships between input and output, even if you don't know whether the original output was correct or not, but if you change the input, there is corresponding change in the output. And if that change is in line with the change in the input, if the change in the output is in line with change in the input, you say my system is behaving correctly. So even if you do not have an oracle, even if you do not know whether your first result was correct or incorrect, that is all okay, doesn't matter. Metamorphic testing can be used for that. So let us go and do metamorphic testing, and we do all sorts of metamorphic testing. So if you look at metamorphic testing, what we did was, in case of image, for example, one of the metamorphic relations between input and output for an image would be, if I rotate my image by any angle, it should still be recognized, classified properly. A giraffe, whether at 90 degree, 180 degree, 270 degree, 5 degrees, still should be recognized properly. And we figured out, for example, in this case, when I change the brightness, when I change the rotation, or when I did shear to my image, or translated the objects within the image here or there, I zoomed in. So all of these should not cause any change in my output, but in many cases, these changes have been found. So this is an example of metamorphic testing that we did, and we found some 47 interesting test cases where the system failed. Now we take this data, we again take it back, retrain the model, and test it again. We find this time the model behaves, in a much better way. So that is metamorphic testing. There are some more metamorphic relations that are there and things that can be done. For example, I could do corner case detection by doing occlusion. Some portion of the image is occluded. Does my model recognize my image properly? I do blur, right? Is it being recognized properly or not? I do contrast change. Is it being recognized properly or not? And so on and so forth. You can see some rotation. You can see example of shear, right, etc., etc. So you've seen now how metamorphic testing can be done and how it can be used to improve the quality of the model. Then there are more things like model privacy, and I'm sort of going to end my presentation in another 5 minutes. So model privacy, you can take a look at model privacy. We have done a lot of different attacks, and you basically are able to reconstruct or get some of the risky data points for different classes, and you are able to do some of these things. So this is an example of model privacy. And then you have model quantization, where we basically reduce the size of the model while continuing with the same kind of accuracy and so on. So from 117 MB, we reduce the size of the model to 15 MB while retaining the exact accuracy of the model. So 8 times reduction and no change in accuracy, or very little change in accuracy. That's what we are able to do. We also do performance testing, and models need to be tested for performance. So that is something that needs to be done. What I showed you was an image pipeline. Of course, you can do the same things for text as well. And this is an example of our tool working on text. And in this case, you can clearly see one particular class is totally skewed. We have a lot of data for one class, less data for other classes, and so on. So I can know even before I start my testing that there is something wrong. Even before I start my training, I know there is something wrong here. So there's a lot of different types of data diagnostics that you can run. You can look at different explainability techniques for text as well. I unfortunately cannot take you into the details, but these are examples. You can do performance testing, you can do stress testing, and so on for text. You can do the same thing for structured data, meaning tabular data as well. A lot of different types of graphs can be plotted. You can do exploratory data analysis. You can look at explainability. You can look at bias. You can look at attacks, right? Metamorphic testing, and so on. So in this whole process of building this tool, using it on a lot of different customer projects, so we pivoted from being a testing services company to being a product company. And the whole idea behind doing services was to learn and basically create new techniques for testing and so on. And despite all that we have done, I can say that today, unfortunately, the industry seems to be in denial. Not really denial, but immature. More and more people are, from 2 years ago, when we went to potential customers and we talked about this, they said, no, I don't think we have a problem. Today, they sit up, take notice, ask us for a demo, and some of them buy. So it's nowhere, where I am very close to being a HP or, any such tool vending company. But it's heartening to see that there are some competitors that have also come now. Um, there are other companies which are trying to do some of the things which are similar to us, but some which are not. Um, People have sort of started to have an appreciation. Many testers have started attending AI testing courses in the last 2 3 years. 3 years we must have trained more than 3,000 people, because a lot of companies have started now doing AI model testing, but they're still not there to this extent that I showed you, because majority of these things are not done at all. And usually you need to do all of these, you need actually good knowledge of what is latest in the industry, what are the latest papers, what is the research that is happening, write your own code or get some open source code, make it work for your product and application and so on. Very time consuming. So the day when testers are able to do all this would be when independent verification and validation, as we used to call that, would become mainstream in AI as well. With that, I end my session and I'm open to questions. Any questions? The silence is really unnerving.
Hello, I think we don't have any questions. So thank you very much for your presentation.
Pleasure.
Maybe we can discuss anything, or like if we have something that you want to say to our audience, something like a tip or a final conclusion, that would be really nice. But I think no questions for now.
All right. Thanks a lot. The platform doesn't give me any feedback about how many people are there, if there is anybody or not. So it is like speaking to a blank wall. But I hope there are some people, and they've been able to take advantage of what I'm saying based on my experience of building the product and actually using the product on customer projects and so on. So if you are in that stream, if you are facing that pain, feel free to get in touch with me outside of this conference as well, and we'd be very happy to share our experiences with you, listen to your experiences, your stories of pleasure and pain, and see what we can do to improve the whole experience.
Yes, I
So
would also like to add that we have a lot of like streams on our social media platforms, but you can also watch our stream afterwards at the A4Q World Congress homepage. And yeah, it's online for a lot of days afterwards. So yeah, you can anytime watch this also after the live session. And yes, we are like really hoping that you get in touch, and thank you very much for your presentation. And yeah, let's connect also on LinkedIn and other channels.
Thank you so much. Namaste once again, and enjoy your day.
Thank you.